So you could have a site that has some harmonics. They're within acceptable limits. By putting a standard power factor correction panel that is not fitted with harmonic blocking reactors, you could create a situation where the harmonic levels become unacceptably high and will result in a reduction in life expectancy of electrical and electronic equipment on site. Hi, I'm Eric from Alpha Power Solutions, and today we're talking about the difference between capacitor banks and harmonic filters. When people research capacitor banks, they usually want to understand how power factor correction equipment or capacitor banks operate and how they reduce the electricity bills. But when they are researching harmonic filters, they usually want to address power quality issues in their business. So the main function of a capacitor bank is to generate reactive power. So when this happens, the utility company, whether it's ESCOM or the municipality, they no longer have to supply that reactive power to your site because you make it locally. As a result, the parent power that you draw from the grid comes down and your electricity bills will reduce. So in other words, it's basically an energy saving device which can result in significant savings in electricity costs. So the function of a harmonic filter is actually to neutralize or reduce the harmonic content or pollution levels that are present in the electrical system. So it's a device that basically improves the power quality within an electrical system. In sites with elevated harmonics, they result in a worsening of the power factor of the electrical supply to that site. And as a result, harmonic filters can also have a positive impact on the electricity bill. So it's a double whammy really for sites that have a lot of harmonics. By putting harmonic filtration in place, you not only improve the power quality, the quality of the electricity inside a specific site, but you also improve the power factor of that site. So you have not only an improvement in quality, but you also have a reduction in maximum demand charges. That is for sites with significant harmonic content. So harmonic filters and capacitor banks are not really competing technology. For business where that generates significant amounts of harmonics, it may be necessary to install both capacitor bank and a harmonic filter for optimal results. And the only way to know that for sure what is required is to record the load profile and the harmonic profile of the site, typically over a period of 1 week. And then you will have all the information that you need to be able to come up with the optimal solution. So standard capacitor banks, and by that I mean capacitor banks that don't have harmonic blocking reactors fitted to each of their steps. If they're installed in an environment where the harmonics are elevated, the capacitors will attract these harmonics towards them and amplify them and raise the harmonic content of the site quite significantly. So this worsens the situation and may increase the harmonic levels to unacceptable limits. And that can then in turn result in damage, not only to the capacitor banks, but also to the supply transformer, as well as the electric and electronic equipment in the site. So you could have a site that has some harmonics, but they're within acceptable limits. By putting a standard power factor correction panel that is not fitted with harmonic blocking reactors, you could create a situation where the harmonic levels become unacceptably high and will result in life expectancy, a reduction in life expectancy of electrical and electronic equipment on site. So if the harmonic levels of a site are elevated, or even before you install power factor correction equipment, you can obviously then install PFC systems that will be fitted with harmonic blocking reactors, and these reactors then prevent the harmonics from being amplified by the capacitors of the power factor corrections. So the only way to know exactly what's required on a particular site is to put a high-speed power quality recorder for a period of approximately 1 week. With that data, we're able to design the right solution for our customers, whether it's simply a power factor correction system or a power factor correction system fitted with harmonic blocking reactors, or purely an active filter or a passive filter, or a combination of the two. We will always try to find the sweet spot when it comes to the investment that is required by the client, while making sure that the solution results in the maximum possible saving for the client. The biggest mistake that we see our clients do is that they partner with the wrong company to address their requirements. Basically, the design of the right solution is actually 99% of the actual work that's required. The actual selection of the equipment that's required, as well as implementation of the solution, is actually pretty straightforward. But the design is so critical. And the only way you can design the right system is that you need the right data. And then you need to be able to interpret the data so that you know what is required. And secondly, basically, is also the installation of the right equipment with the lowest lifecycle costs. That's what's key. And not so much the initial investment. The equipment with the lowest cost is usually the ones with the highest lifecycle cost. So for certain sites, the cheapest option might be to install static VAR generator rather than capacitor banks. So this is a technology used in equipment that is similar to active harmonic filters. And it is even possible to fit the two technologies together, we being the static VAR generator and the active harmonic filter inside a single enclosure. Again, having the right load profile and harmonic profile data from the customer will determine whether that technology will offer the lowest lifecycle costs. There is places where that technology makes a lot of sense, and there's sites where capacitor banks actually offer the lowest lifecycle cost and the best return on investment. That's it. Well, thanks for watching. If you found this helpful, please like and subscribe. There's a blog with more information linked in the description below.